In number 85, we have a toy plane. It is tracing out a horizontal loop of radius 0.44 meters. We do not know how long the string is. We do not know what the angle is. The angle is what they are asking for in part A. How much the tension is what they're asking for in part B. We do know that the plane has a mass of 0.075 kilograms and has a velocity of 1.21 meters per second. Okay. Now, let's start with the first part for our angle. Let's see what we can figure out. In the horizontal direction, which is of course your x direction, we have an acceleration. In the y direction, we do not have an acceleration. It is stable, so that means that my weight is equal to an upward force. That upward force must be the tension in the y direction. So that means my tension goes up to about here, according to my picture. And so that's the tension that we're solving for. Now, tension in the y direction is the same thing. Now that angle also occurs down here, so that is the adjacent side. So that means that the forces to the left are the tension in the y direction. Upward force is tension in the y direction, downward force is the weight. My tension in the y direction is the tension times the adjacent side, so that's cosine of theta is equal to the weight. The weight is, of course, mass times gravity. Well, that didn't get me very far because I have both of my unknowns at the same time. This looks like a problem where we're going to have two equations with two unknowns in order to solve for them. So let's take a look in the y direction. In the y direction, we do have a net force. The net force is very obviously the tension in the x direction. And the tension in the x direction is the centripetal force. So, my centripetal force equals mass times velocity squared divided by radius, and it happens to be equal to the tension in the x direction. That means T times the sine of theta is equal to mv squared over r. Let's get rid of tension, so we'll substitute in. We'll solve this one up here for tension, then substitute it in there. So that means that my tension is equal to mg divided by cosine of theta. Now I'm going to take this, set it equal to, whoops, this isn't solved for tension either. Tension equals mv squared divided by r sine theta. This tension equals that tension. So that thing and that thing are what are set equal to each other to make the tension go away. We're left with some sines and cosines. I'm hoping I get a tangent out of this thing. So we've got mg over cosine theta equals mv squared over r sine theta. Mass goes away. Doesn't matter what the mass of the airplane is. It was extra information. Now, we will need it later on when we find the tension, which we can use this formula or that formula to find the tension once we find the angle. If I put my sine theta up here, what I end up with is sine theta divided by cosine theta, which we of course all know is tangent theta. Alright, my g's got to come down here, so I've got on the other side v squared over r times g. Piece of cake. V squared is 1.21 meters per second squared, not squared, meters per second, and that whole thing needs to get squared, divided by r, which is 0.44 meters, multiplied by g, which is 9.81 meters per second squared, and let's see, might as well throw it out here. 1.21 squared divided by, 1.21 squared divided by 0.44 divided by 9.81. That's 0.34. And the inverse tangent of that gives me that theta. Alright, so I've got 0.34. Inverse tangent gives me 18.7 degrees. Which I know I've got two sig figs, so that's 19 degrees, which is the correct answer. Now I'm going to plug in my 19 degrees up here. I suppose that one was a little bit easier, but oh well. Don't have enough room up there. Mass is 0.075 kilograms. V squared is 1.21 meters per second, getting squared again. Divide that by my radius, 0.44 meters, and multiply that in the denominator by sine of 19 degrees. All right, let's see what we got. We have 0.075 times 1.21 squared divided by 0.44, and then again divided by the sine of 19 degrees. That gives me a tension of 0.77 newtons. They had 0.78, so a little bit of round off error someplace, but those are the correct answers. Thank you for watching with us.